Okay. Good afternoon. And a quick reminder that your term test 1 will be held on October 2nd. And it will start at 7 p.m. and 9:30 p.m. You're going to have 3 questions. I will notify about your sitting arrangement on Friday, which room you should go to. 3 questions, and they are from the lecture. Okay, so you need to know the lecture notes, okay, from lectures. Okay, and homework 01, homework 02, and homework 03. You should be capable of doing all this homework without any problem. Okay, yes. Yep. Homework 3 is also involved. Okay. I can add in some more formulas for what I teach this week. Okay. I know you're worried, but that's the last thing I want you to feel. Yes. I saw a hand back there. Hey? Say it again. No, it's going to be in T13 on Friday. I'll let you know the place and the location on Friday. Okay? Yes. Yes. Okay? So everything. Okay? So that is a very good concern. That is why I'm doing 2 more examples today. Okay? I know yesterday I only showed 1 example is not enough. I'm aware of that. Any other questions? Yes. Hey? Yeah. Don't look at my kindness as weakness. Okay? The fact I post the solution at the same time, I don't have to panic because you got no one to ask. Okay, you can refer. Yes. For which one? So there's C1 plus by C2 T bracket E minus alpha T. Is my T missing? Oh, there's no T. Thank you for telling me. Is the T missing? Okay, my apologies. Yesterday, not a fun day for me. Any other questions? Yes. Oh, I forgot to put my mic on. Thank you for telling me. Sorry about that. Can you hear me now? Testing, testing. 4, 5, 6. Good. Right. Hi, Sylvie. Okay, I remember you only, unfortunately. I'll try to remember the rest, okay? And he said, yeah, he derived the whole freaking mechanical vibration, cannot even remember my name. Right. So we are going to look at another examples. Okay. We're going to look at another example, and they are posted on Avenue to Learn. So this is the next example that we'd like to do. Okay. So this example is different from the previous one. Is because I selected this example because there are more gears. But does not mean more gears, more difficult. Not necessarily true. Right, let's see what we have. Okay. So we have a short time motor turn gear A, right? So you see gear A down here in the diagram with an angular acceleration. So we know that alpha A is equal to 30 T power of half radians per second squared, where T is in seconds. We have to determine the angular velocity of gear D. Okay, we have to find omega D. Okay, we have to find omega D. Okay, when T is at 5 seconds, and we know that omega A, omega B, omega C, omega D is equal to 0 radians per second when time is equal to 0. Okay. Furthermore, we are given a radius of A. We are given a radius of B. The radius of A is 0.025 meters. Radius of B is equal to 0.1 meter. Radius of C equal to 0.04 meters. And radius of D is equal to 0.1 meter. Okay. So a question like that, unfortunately, they do have a lot of layers. Okay. So coming back, we somehow have to sketch our simplify the entire structure, okay, of gears. Okay. So we're going to have a transformation now. I'm going to, for no reason, I'm going to call this X. I'm going to call this Y. And I'm going to address this as Z. Okay. Just randomly. Okay. So now we are going to view at this section, we are going to view the structure that we're going to analyze. And this is our X, and that's our Y. Okay, so our eyes that we're going to view is over here. Okay, so that's where we are. We are looking at. So we know that gear B and gear D. So I'm going to sketch our gears first. Okay, so I'm going to go into this mode. So I'm going to sketch our, okay, Eugene, come on. I'm going to sketch our gear B. Okay, so this is our gear B. And then we have our gear C sharing the same shaft. Okay, so this will be our gear C. Sorry, gear C, right? So given that this is our gear C, and then we have a gear D. Okay. And if I'm not wrong, if you look at the dimension, gear D and gear C has the same dimension. Okay. But it has been offset. So again, this is just a sketch. It has been offset. And I hope this is my, yeah, I hope this is my center. So this is our gear D. And from there, we have our gear A from that view. Okay, just draw a simple sketch. This is our gear A. Okay. So this is a simplified sketch. Okay. I find really useful. Useful in doing what? Okay. Why do I find this useful? Useful in doing what? Remember, the topic that we are teaching now, can have anyone has any idea what is the chapter that we're teaching now? So the chapter we are teaching now is known as chapter 16, planar kinematics of a rigid body. The elaboration is planar kinematics. So you all understand what is planar now, yes or no? If this thing is going to move, it's going to move in which plane? XY plane only. Okay, and we are just going to do rotation. Why the term rigid body? Okay, why the term they use rigid body? Okay, this is why. Okay, so as you can see, gear B and gear C are attached by a common shaft. Yeah, go? Yes or no? Right? So you will write this note that gear B and C, okay, gear B and C share the same shaft. So when you declare that, therefore, the angular velocity of gear B is equal to angular velocity of gear C. And we are going to assume that it is a rigid body. Okay. Now, this assumption we make is to simplify our analysis. I repeat again. This is to simplify an analysis. Okay. In real life, they might be having a bit of what? Twist. Okay. We're going to ignore the twist for now. When we go to chapter 17 or 18, we have to consider the twist. Now, early days, honeymoon period, enjoy life. So when I see a problem like this, I start to worry. Like when you see a problem like this, or when I do it the first time, I don't know where to start. Okay. Always remember what is given to you. Okay. So given to us is alpha. So somehow we have to relate alpha to omega A. Okay. Why omega A? Because in the end of the day, we are going to find what? Omega B. Okay. So I write down here why need to find okay, why we need to find omega A. So if we look at gear A to gear D, they are somehow connected. Yes or no? Gear A to gear D are somehow connected. We know that omega A, RA is equal to omega B, RB. Yes, we know that. Okay. Oh, by the way, you all had 2D yet today? You all learn about gears? 2D or 3? You all learn about gears today? A bit about gears? Excellent. Seems to be in time. So this is one called. So gear A and gear B are related by omega A, RA, omega B, RB. Then the next relationship that we can bridge is omega B is equal to omega C because they share the gears share the same shaft or the same shaft. And finally, we can also have the analysis where omega C RC is equal to omega D RD. So with this, we can find what? Omega D. That is our end objective. Are we clear? That is why it's so important to have a diagram like this, okay? And how are we going to relate our acceleration at point at gear A? Okay, so we know how to relate. Okay, so if we were to look at the formula, right? So we know that omega is equal to, so relating